Hello everyone, welcome to Grade Up. My name is Himanshu Mittal and today in this lecture we will study matrices and determinants. So we will cover these topics in this lecture. What is matrix? What are the types of matrix? What is a determinant? And how to calculate the inverse of a matrix and where it is used? What are the different properties of matrices and determinants? And what is the rank of matrix? Most of the questions in GATE examinations are based on these two topics. What are the properties of matrix? Most of the questions you will find from these two topics. Okay. So we will first start with what is a matrix. See, it is an arrangement of elements in a row and column manner. Suppose this is a matrix of n cross m. Okay, where n is the number of rows and m is the number of columns. Row is this and columns are this. So suppose there are n rows and n columns, so total number of elements in a matrix will be n into m, that is mn. Okay, suppose we will take an example of 2 cross 3 matrix, 1 0 1 2 1 0. So there are 2 rows in this matrix and there are 3 columns in this matrix. Okay, so now we will see what are the different applications of matrix. In each and every engineering discipline we have the application of matrix. Suppose from electrical or electronics point of view, we will see 2-port networks. So what are different 2-port networks? That is Z matrix, Y matrix, H matrix, G matrix, and there are total 6 2-port networks. Each and every 2-port network is related with respect to each other. So, for example, there is some relation between H matrix and Z matrix. Only electrical and electronics students read these topics. For example, from civil engineering point of view, you may have heard about structural flexibility matrix and stiffness matrix. They are the inverse of each other. And in mechanical engineering also you have heard structural analysis also. So in each and every engineering discipline you will find some application of matrices. So this is a very important topic from GATE point of view. Okay, now we will see what are different types of matrices. See, first is diagonal matrix. Second is null matrix. Third is identity matrix. Fourth is triangular matrix. There are 2 types of triangular matrix. First is upper triangular and second is lower triangular. We will see one by one what are the different types of these matrices and how we form these matrices. Okay. First we will see diagonal matrix. In a diagonal matrix, only diagonal elements have some values while all other elements will be 0. For example, we take a square matrix of 3 cross 3. Only square matrices. Square matrices are those matrices in which number of rows and number of columns are equal. Only for square matrices we have diagonal matrices. So diagonal elements are A11, A22 and A33. All these elements A12, A21, A13, A21, A23, A31, A32. Only these elements will have some value while all other elements will be 0. So the example of diagonal matrix is 1, 4, 3, while all these elements are 0. So this is one example of diagonal matrix. Now we will see null matrix. Null matrix is simple, as the name signifies. All the elements of the matrix are 0. All the elements of a matrix. We took 2 cross 3 matrix and all the elements of this matrices are 0. So this is null matrix, while this is diagonal matrix. Okay. Third is identity matrix. Identity matrix is a special type of diagonal matrix. In diagonal matrix, the diagonal elements can have any value. While in identity matrix, the diagonal elements will have only one value, that is equal to 1. So this is an example of 3 cross 3 identity matrix. This is an identity matrix. Now we'll see triangular matrix. First is upper triangular and second is lower triangular. Okay, what is upper triangular matrix? All the elements of lower triangular will be 0, while upper triangular matrix will have some values. For example, so this is a lower triangular. This lower triangular will have 0 values, while all other upper triangular matrix have some values, or some of the elements may have 0 values also. This is an example of upper triangular matrix. While in lower triangular matrix, all the upper triangular matrix elements will be 0. So the upper triangular elements are 0, while lower triangular elements have some values. So this is an example of lower triangular matrix and this is an upper triangular matrix. Okay, now let's move to the third, determinants. How to find the determinant of a matrix. So we can find the determinant of a square matrix only. We cannot find a determinant of a 2 cross 3 matrix. There is no determinant of a 2 cross 3 matrix. So if a matrix is of square like n cross n, then only we can find the determinant of that matrix. So how to find the determinant? We will start with a simple one of a 2 cross 2 matrix. This is a 2 cross 2 matrix and the determinant of this matrix is cross product of these two elements minus cross product of these two elements. So 1 into 5, that is 5, minus this is determinant of A matrix. This is A matrix and the determinant symbol is represented by this. So determinant of this matrix is cross product of these two elements minus cross product of these two elements. So 5 minus 8, that is equal to minus 3. This is a determinant of a 2 cross 2 matrix. Now suppose we have to find the determinant of a 3 cross 3 matrix. This is a 3 cross 3 matrix and we have to find the determinant of this matrix. So how to find determinant? First we will take first element of any row or column. First element of, suppose, first row. Then remove first row and first column and take all other elements, this square matrix. Now determine the determinant of this matrix. So the formula is 1 multiplied by determinant of this matrix is 5 into 3 minus 2 into 1 minus second element 4 into, remove this row and this column. We are left with 3, 1, 6 and 3. Now determine the determinant of this matrix. So 3 into 3 minus 6 into 1. Now take third element 2 plus 2. With first element we took positive sign, with second element we took negative sign, and with third element we will again take positive sign. So determinant of now this matrix 3, 5, 6, 2 is 3 into 2, 6 minus 6 into 5. Now let's calculate the determinant. 15 minus 2, 13 minus 4 into 9 minus 6, 3 plus 2 into 6 minus 30. that is minus 24. So this is 13 minus 12 minus 48, that is equal to minus 47. So the determinant of this matrix is minus 47. Determinant can be any value, it can be positive or it can be negative also. Now let's move to the important concept, that is inverse of a matrix. Before finding the inverse of a matrix, we will have to familiar with some terms of the matrix, that is trace of a matrix, transpose of a matrix, minors of a matrix, cofactors of matrix, adjoint of matrix. These are the terms we need to be familiar with, and how to find these trace, transpose, minor, cofactor and adjoint with the help of a matrix. Okay. First we will see how to find a trace. So trace is a sum of the diagonal elements of a matrix. We can only find the trace of a square matrix. Okay. So what are the diagonal elements of this matrix? A11 and A22. Sum of these two elements is called trace. So trace of this matrix is equal to 2 plus 4, that is equal to 6. Simple. This is the trace of matrix A. Okay. Now we will find transpose of a matrix. For transpose, rows are made into columns and columns are made into rows. For example, see, we will find the transpose of this matrix only. First row is converted into first column of this matrix. So first row is 2, 3. So row is converted into column and second row is converted into second column. So 2, 3, 6 and 4. This is the transpose of this matrix. Okay, for 3 cross 3 matrix, first row is converted to first column, second row into second column and third row into third column. Simple. Now we will find the minors of a matrix. We again take same matrix 2, 3, 6, 4. Now minors of a matrix is, every element has a minor. For example, this element A11. A11 has a minor by, first we remove first row and first column, because A1, we took A11 element. So if we remove first row and first column, then we are left with 4. So 4 is the minor of A element A11. We will write 4 here at A11. The minor of element A12 is by removing row 1 and column 2. So we are left with 6 here. So 6 we will get here, and 3 we will get here, because minor of A21 is 3 and minor of A22 is 2. Okay, this is the minor matrix of this. This is minor of this matrix. Okay, now how to find cofactor of matrix? From minor matrix, we have to find cofactor matrix only. Cofactor matrix is, we will first sum the element number. Suppose this is A11, A12, A21 and A22. Okay, we will sum these two numbers. Sum of row number and column number. Sum of row number and column number is 1 plus 1, it is 2. The cofactor matrix is just minus 1 to the power sum of row and column. Minus 1 to the power, I will write minus 1 to the power m plus n, where m is the row number and n is the column number. If we multiply this matrix with this, then we will get the cofactor matrix. So minus 1 to the power 1 plus 1, 2. So this is positive only. We will get 4 here. Each element is multiplied with minus 1 to the power m plus n. for this element 1 plus 2. So 1 plus 2 is 3 minus 1. We get minus sign here, minus 6. For this is 2 1. This element is a 2 1. So we will put 2 here and 1 here. We get minus 1 to the power 3. We get minus 3 here. And for this we got even number. So here it is 2. This is the cofactor matrix. Now we will see minors and cofactors for a 3 cross 3 matrix. Now see the minors and cofactors for a 3 cross 3 matrix. Let me take an example for this. Suppose we have a 3 cross 3 matrix A. This. Now we will find minors of this matrix first. Minors of A. Okay. For minor of element A11, we get this matrix. Okay. Now to determine the determinant of this matrix, we know how to determine the determinant, that is 0 minus 0. So we get 0 here. Now for A12 element, we will determine determinant of 1 0 0 1 matrix, because we will remove this row and this column. So we are left with 1 0 0 1. Okay. So determinant is 1 into 1 minus 0, that is 1. Now determinant of this matrix 1 0 0 0, because we will remove this arrow and this column. So determinant is 0. Now minor of this element is 1 into 1 minus 0, that is 1. Now minor of A22 element, it is 0 minus 0, that is 0. Okay. Determinant of minor of this element 0, we get 0 minus 0, it is 0. Minor of this element is 0 minus 0, 0. Minor of this element is 0 minus 0, 0. And minor of this element 1 is 0 minus 1 is equal to minus 1. This is the minor matrix. Now we will find cofactor matrix. Cofactor matrix, as I told you, multiply this matrix with minus 1 to the power m plus n. Okay. So this is first row and first column. So 1 plus 1, it is 2. So minus 1 to the power 2 is equal to plus 1. So we get 0 here. Again for element 1 2, A12 we put 1 here and 2 here. We get minus 1 to the power 3, that is negative sign. So we get negative sign with this element. Again we will multiply minus 1 to the power 1 plus 3, 4. That is even number. So we get plus 0. Again this will be minus 1, this will be plus 0, minus 0. The signs will be alternate only. So here we get 2 1. So 2 1 is positive, 2 1 is negative. So we get minus 1. Then it will be positive. Then element 2 3, 2 3 is odd, so negative. 3 1 is positive even number, so we will get positive sign. Then 3 2 is odd number, so we will get negative sign. Then 3 3 is 3 3 sum is even, so we will get same sign, minus 1. This is the cofactor matrix of this matrix A. I will let it right here. Then I will find adjoint of this matrix. Adjoint of a matrix is just the transpose of cofactor matrix. So as I told you, adjoint is the transpose of cofactor matrix. So I will write rows into columns and columns into rows. So adjoint of matrix A is transpose 0 minus 1 0. I will write 0 minus 1 0 here, minus 1 0 0, minus 1 0 0, and then we get 0 0 minus 1. So 0 0 minus 1. This is the adjoint of matrix A. The matrix A was, you may remember, adjoint matrix A was 0 1 0 1 0 0 and 0, 0, 1. This was matrix A. We get adjoint of matrix A as 0, minus 1, 0, minus 1, 0, 0 and 0, 0, minus 1. Now we will find the inverse of a matrix. The final step is inverse of a matrix. But before finding the inverse of a matrix, we also need determinant of a matrix. Determinant of a matrix is, as I have already told you, we can find from this matrix, from A. So this is 0, so we get 0 into some value, that is 0 into 1, 0, minus 0, minus 1 into 1 into 1, 1 into 1 minus 0 into 0. So 1 minus 0 plus 0 into 1 into 0, 0 minus 0 into 0. So this is the determinant of matrix A, that is equal to minus 1. So we get adjoint here and determinant here. And finally, we are going to find the inverse of the matrix A. Now, the inverse of a matrix A. This is the representation of inverse of matrix A to the power minus 1. It is given by the formula adjoint of A divided by determinant of A. That is equal to adjoint of A is 0, minus 1, 0. Minus 1, 0, 0 and 0, 0, minus 1. 0, 0, minus 1. This is adjoint A and determinant A is minus 1. So 1 by minus 1. If we solve this, we get 0, 1, 0, 1, 0, 0 and 0, 0, 1. This is the inverse of matrix A. This is matrix A and this is the inverse of matrix A. Here we get same because here we get same as A matrix. Inverse of matrix A is same as the inverse of A matrix. So this is by chance, every time we will not get the same value. Now let's move to the important topics of matrix, that is properties of matrices and determinants. So we will see what are the properties of matrix. First property is A cross B transpose. A cross A into B transpose is equal to B transpose into A transpose, and which is not equal to A transpose into B transpose. Remember this. This is equal to B transpose into A transpose, but not equal to A transpose into B transpose. Okay. Second, this is the first property. Second property is transpose of a transpose is equal to the same matrix. If we transform row into columns 2 times, then we again get rows matrix. So A transpose of a transpose is equal to the same matrix A. Third property is K into A transpose is equals to K into A transpose. This is KA. K is inside matrix A. It is multiplied with each and every element, and then we took transpose of that matrix, which is equal to K. It is outside the matrix and transpose of matrix simple A. Okay. Fourth property is sum property. It is distributive in nature. A plus B transpose is equal to A transpose plus B transpose. If we distribute A and B separately, then we will get same result. Now determinant A is equal to determinant of transpose. So transpose matrix has same determinant as a simple matrix A. Sixth property is, this is very important property. For triangular matrix, for a triangular matrix, determinant A is, what do you think, what will the determinant of a triangular matrix? It is product of diagonal elements. What is it? It is a product of diagonal elements. It is a product of diagonal elements. Okay. Let me show you how. Suppose we got 3 cross 3 matrix 1 2 3 0 4 0 0 0 2. Okay. Now if we solve determinant with the help of this column, then we only get this first value and determinant of 4 into 2. So 4 into 2 is 8. Suppose if we have some value here also, no problem. 1 into 4 into 2, 8 minus, let me write determinant here, 1 into 4 into 2, 8 minus 0 into 5, that is 0. Again minus 0 into, we will multiply 0 with any value, we get 0 here, and then we will multiply 0 with any value, we will get 0 here. So determinant is 1 into 8, that is 8. So verify it with this property. Determinant of a triangular matrix is product of diagonal elements, and the product of diagonal elements is 1 into 4 into 2, that is equal to 8, and we verified this result with the help of this example. Okay. Now we will see seventh property. Seventh property is inverse property. Determinant of a inverse of a matrix is equal to 1 by determinant A. Okay. Determinant of inverse of a matrix is just the inverse of determinant A, that is equal to determinant A to the power minus 1. Okay. Next property is, what is the determinant of adjoint of a matrix? So many times questions was asked based on this property only. What is the determinant of a adjoint of a matrix A? So adjoint of a matrix A has a determinant equal to determinant of A to the power n minus 1, where n is the row of the matrix or column of the matrix, because we will find adjoint of a matrix only of a square matrix. So in square matrix, number of rows and columns are equal. So n here is either you can take number of rows or number of columns, it is equal only. Next we will see what is adjoint of a matrix. So adjoint of a matrix is equal to determinant of A to the power n minus 2 into A. A matrix is multiplied by determinant of A to the power n minus 2, where n again is the number of rows or columns. 10th. This is also very important property. What is the determinant of adjoint of A? So we will derive this property with the help of this property only. So as we know, so let me write one property also before deriving this property. This is also very important property. CA determinant is equal to C to the power n determinant A, where n is the number of rows or columns and C is multiplied with the whole matrix. Okay. So now we will derive 10th property with the help of this. What is the determinant a to the power n minus 2? It is a constant only, that is equal to c. So it is same as CA. CA is determinant a to the power n minus 2, where C is a determinant a to the power n minus 2 and A is a. It is equal to C to the power n determinant A. So C to the power A is determinant a to the power n minus 2 into n into determinant of A. Okay. C. Determinant of n minus 2 into n is n square minus 2n. Determinant of n square minus 2n into determinant of A. Into is plus 1. Okay. So this is equal to n square minus 2n plus 1 is n minus 1 whole square. So determinant A to the power n minus 1 whole square. Okay, this is the determinant of adjoint A, determinant a to the power n minus 1 whole square. As we have seen some properties of the matrix, now we will move towards the rank of the matrix. We will also see some questions based on the properties after rank of the matrix, after we will read this concept of rank of a matrix. So what is a rank of a matrix? There are basically first only one definition which contains 2 points. So what are those 2 points? Let me write definition first. What is the rank of a matrix? A matrix is said to be of rank R A matrix is said to be of rank R when, first, all the minors of order higher than R vanishes. I will explain these 2 points in detail after writing these 2 points. And second point is, at least one of the minor of order R should be there, should not be non-zero. At least one of the minor of order R is non-zero. Okay, what are the 2 conditions? All the minors of order higher than R vanishes, and second is at least one of the minor of order R is non-zero. So let me take example of a rank R matrix. I will take a 2 cross 2 matrix. Suppose 2 cross 2 matrix is 1, 2, 3 and 0. So minor, first we will determine, okay, let me write 1, 2. Suppose a 2 cross 2 matrix is 1, 2, 3 and 6. Now we will determine the determinant of this matrix. The determinant of this matrix is 6 minus 6, that is equal to 0. So the minors of 2 cross 2 to order 2, 2 cross 2 means order 2 is 0. So first condition is all the minors of order higher than R vanishes. If order 2 is vanished, then we will move towards order 1. Now the minor of order 1 matrix, that is 1 cross 1, minor of 1 is 6, that is non-zero, while the minors of order higher than 1, we already got minor of order 2 is 0 and minor of order 1 is non-zero. So the rank of this matrix is 1. So let me take one more example. 6, 0, 4, 4, minus 2, 14, 8, 18, 14, minus 14, 0 and minus 10. This is a matrix of 3 into 4. So we can't get minor of order 4 here because 4 into 4 matrix is not present in this. So we get only 3 cross 3 matrix. But it is very difficult to find determinant of 3 cross 4. We get 4 3 cross 3 matrix here, because if we remove first column, then we get this minor of order 3. If we remove second column, then we get minor of order 3 of these two columns. So we get 4 matrix of order 3 here. So it is very difficult. So we will use some trick to solve this to find the rank of this matrix. Okay, transforming first row with second row. R1 is interchanged with R2. Minus 2, 14, 8, 18, 6, 0, 4, 4, 14, minus 14, 0 and minus 10. Now we will make first column these two elements 0. So we will apply transformation here. R2 is replaced with R2 plus 3 R1. Okay, and R3 is replaced with R3 plus 7 R1. Okay, so let me apply these two operations. So we get R1 row as it is, minus 2, 14, 8, 18, 0, 0 plus 3 into 14, 42, 4 plus 3 into 8, 4 plus 24, 28, 4 plus 54, 58. We get 14 plus 2, 7 into minus 2, 0, minus 14 plus 7 into 14. 7 into 14 is 112. 14 into 7 is 70 plus 98. We get minus 14 plus 98, it is 84 here. Then we get 0 plus 7 into 8, 56. Then minus 10 plus 7 into 18. 18 into 7 is 126, minus 10, that is 116. Now we can see that R3 matrix is just, R3 row is just double of R2 row. So we will apply the operation R3 is R3 minus 2R2. Now as we have covered all the topics, so we get here, now we will apply operation R3 is R3 plus R3 minus 2R2. So the matrix will be minus 2, R1 row as it is, minus 2, 14, 8, 18, R2 row as it is also 0, 42, 28 and 58. These two rows are as it is because we have applied operation on row third only. So third row will be 0 minus 0, 0, 84 minus 2 times of 42 will be 0, 56 minus 2 times of 28, 0, 116 minus 2 into 58, that is 0. So this row is 0 now. So we get only 2, since minors of order 3 are vanishes because of vanishing of row 3, we are only left with 2 cross 2 elements. So now we can easily determine determinant of order 2. Determinant of order 2 is minus 2 into 42, that is minus 84, minus 84 minus 0, that is equal to minus 84. Since the minor of order 2 is not equal to 0, while minors of order 3 are 0. So the rank of this matrix is 2 only. Okay. So what we have, let me revise this question once again. First we transformed row first with row second. We get minus 2 row here and 6 first row at the place of second row. Then we'll apply these two operations. Why we applied these two operations? Because we need to make these two elements. Always remember, you need to make all the elements 0 after first element. Okay, all the elements of first column after first element should be 0. So we get this matrix after applying these two operations. Then as we can see, this row, third row, is twice of second row. So we applied operation R3 is R3 minus 2R2. Then we get third row as 0. Then since we have seen that third row, the order of minors of order 3 are 0 and minor of order 2, we get here minus 84. So the matrix is of rank 2 according to the definition that I have given you earlier. Okay. Now let's move to the questions now. Okay. We will see first question. This question was asked in 2014 in mechanical engineering. So the question is, which of the following is correct identity of matrix? First is P into Q plus R is equals to PQ plus RP. Let me write first option here. P into Q plus R is equals to PQ plus RP. But as I have told you, A into B is not equal to B into A. This is the property of matrix. So P into Q is PQ plus PR, but they have written here PQ plus RP. PR is never equals to RP, so the first option is incorrect. Now we will see second option. Second option is P minus Q whole square equals to P square minus 2PQ plus Q square. P minus Q whole square should be equal to, I will write what should be it equals to, P square minus PQ minus QP plus Q square. And since we know that PQ is not equals to QP, so we can't write PQ equals to, we can't write PQ and QP equals to 2PQ. So this is also wrong. First and second options are wrong. Now we'll see third option. Third option is determinant of P plus Q is determinant of P plus determinant of Q. So the third option is determinant of P plus Q equals to determinant of P plus determinant of Q. This is not true. Determinant is not a distributive property. I have told you transpose is a distributive property, but determinant is not a distributive property. So this option is also wrong. We will see fourth option now. Fourth option is P plus Q whole square equals to P square plus PQ plus QP plus Q square. Now we will write P plus Q whole square. We can write P plus Q into P plus Q. This is equals to P into P square plus P into Q, that is equals to PQ plus Q into P, that is equals to QP plus Q into Q, that is equals to Q square. So this option is matching with the fourth option. So this option is correct. Okay. So we get fourth option as correct one. Now let's see one more question. So the question is, it is given that determinant of a some matrix is equals to minus 7. Then we have to find the determinant of second matrix with the help of first matrix. So I will write first matrix here. 1, 3, 0, 2, 3, 4, minus 2, 0 and 1. The determinant is given here as minus 27. Now we have to find the determinant of second matrix, that is 2, 6, 0, 2, 3, 4, minus 4, 0, 2. So as we see, second row is as it is second row, while first row is twice of first row here. First row is twice of first row and third row is also twice of third row. According to the properties of the determinant, if first row is multiplied with 2, then determinant is also multiplied by 2. So we get, or if only first row is multiplied, then we get determinant as minus 27 into 2. But here third row is also multiplied with 2. So we get determinant as twice of the given determinant, that is minus 27 into 2 into 2, which is equals to minus 108. It is equals to minus 108. So this is a very simple property. If a row or a column is multiplied some constant, then we get determinant as the constant multiplied by the given matrix determinant. So here 2 into minus 27 into minus 2, that is equals to minus 108. Let's move to the another question. Third question is the maximum value of determinant among 2 cross 2 real symmetric matrices with trace 14 is. So what is the question is asking is, there is a 2 cross 2 real symmetric matrix. So we will first see what is a symmetric matrix. A symmetric matrix is something which has a column Aij equals to, element Aij equals to Aj I. So suppose element A12 is something 2. Then in a symmetric matrix A21 is also equals to 2. This is a property of the symmetric matrix. Now the question is the maximum value of determinant among 2 cross 2 real symmetric matrix with trace 14. You know what is a trace? Trace is the sum of diagonal elements. Suppose the matrix is, it is a symmetric matrix, it is given. So the matrix is A, B. If A12 is C, then A21 is also equals to C. Now we have to find the maximum value of the determinant. The determinant value of this matrix is A into B minus C square. The maximum value of this matrix can be only when C square is always a positive number. If we subtract a positive number from some value, then we also always get a some less value. So we have to first make C as 0 so that we get maximum product because of A into B. So we get one constant here, C equals to 0. Then A into B is equals to maximum. We have to maximize A into B. But here it is given that trace is equals to 14. Trace is A plus B is equals to 14. If A plus B is equals to 14, then A into B is maximum when? Only when we can find it with the help of calculus, or we directly know that A into B is maximum when A is equals to B, or I can prove that if A plus B is equals to 14, then A into B is maximum when A is equals to B is equals to 7. So let me prove how I am saying this statement. Okay, it is given A plus B is 14. A into B is equals to, suppose A into B is some Y, value Y. Here B in terms of A is given by B equals to 14 minus A. So A into 14 minus A is equals to 14A minus A square. Now we have to maximize A into B. So we have to maximize Y. To maximize Y, we need to find the differentiation of Y with respect to A. dy by dA is equals to 14 minus 2A. Now we have to equate it to 0. If we equate this equals to 0, then we obviously got A equals to 7. So I am saying A is equals to 7 here. If A is equals to 7, then B is also equals to 7. So maximum of A into B is 7 into 7. So Y is equals to A into B is equals to 7 into 7 is equals to 49. So determinant as we got determinant as a into b minus c square, we get c equals to 0 and a into b equals to 49. So determinant of this matrix a is equals to 49 according to the question. This is the question only, it is asking for the maximum value of the determinant. So the maximum value of the determinant is 49. You got it? Let's move to the next question. The question is, let A1, A2, A3 and A4 be 4 matrices of dimensions given such as 10 into 5, 5 into 20, 20 into 10 and 10 into 5 respectively. The minimum number of scalar multiplications required to find the product A1, A2, A3, A4 is using the basic matrix multiplication method is. So what is the question asking here is, what are the minimum number of multiplications required for determining the product of these 4 matrices, and the order of these 4 matrices is given as something. First, let me tell you how many number of multiplications are required for multiplying a matrix A into B with B into C. First we will see what are the minimum number of multiplications required to multiply these 2 matrices. So A into B matrix is, number of rows are A and number of columns are B. Okay, this is A into B matrix, and this is B into C matrix, where number of rows are B and number of columns are C. Okay, suppose I'll write 1, 2, 5, 6 and here it is 3, 4, 7, 8. So number of multiplications are, if I took B equals to 4, so number of multiplications here are 1 into 3, 1 multiplication, 2 into 4, 1 more multiplication, 5 into 7, 1 more multiplication, 6 into 8, 1 more multiplication. If we have to multiply these 2 matrices. So number of multiplications is equal to 4. Okay, for obtaining one element only, one element of A cross C matrix, for obtaining one element of A cross C matrix is equals to 4, where 4 is equals to B, because I have taken B equals to 4 here. Okay, so number of multiplications required are 4. So there are total A into C elements in A cross C matrix. So therefore total number of multiplications required in multiplying A cross B matrix with the help of B cross C matrix is equals to A into C into B, where B is 4 here and A into C are the number of elements of a matrix. Okay, now we will solve the question. We have seen that multiplying A into B with B into C matrix is equals to A into B into C. These are the total number of matrix multiplication required for multiplying A cross B matrix with B cross C. Now the question is asking for minimum number of multiplications required to multiply these matrices. So the matrix are given as 10 into 5, 5 into 20 and 20 into 10 and 10 into 5. These are the dimensions of 4 matrices. See, since B is multiplied only once, so we have to choose B such that it is the maximum value, because we have to multiply B only once while A and C are multiplied this only. So if we take, suppose if you are saying that we first multiply these 2 matrices and then we will see, then the number of multiplications required will be 20 into 10 into 5, that is equals to 200 into 5, 1000. 1000 multiplications are required to multiply these matrices. Then we will multiply 20 into 5 matrix with 5 into 20 matrix. So 5 into 20 into 5 is 5 into 20 into 5 is 25 into 20. That is equals to 500. Then we get 5 into 5 matrix. Then multiplying 10 into 5 matrix with 5 into 5 matrix, we get 10 into 5 into 5. That is equals to 250. So total number of multiplications is 1000 plus 500 plus 250. That is 1750. But this is not the minimum number. Why? Because we have multiplied 10 this matrix first, these two matrices first. But if we multiply these two matrices first, then we will get different answer. We got 1750 if we multiply these two matrices. Now we will see we will see what is the answer if we multiply these two matrices first. Then we will get 5 into 20 into 10. So number of multiplication required equals to 1000. Then we get 5 into 10 matrix. Okay. Now if we multiply first these two matrices, because 10 is a bigger number than 5. See, I will explain to why I am taking this, because it is multiplied only, b is multiplied only once, and the bigger number has to be only once. Then we will get the minimum value only. If we take a smaller number once, then we will get a larger value. Okay. So to get a smaller number of multiplications, we have to take larger number only once. It should not be twice. So if we multiply 5 into 10 matrix with 10 into 5 matrix, we will get number of multiplications equals to 5 into 10 into 5. That is equals to 250. Okay. Then we get matrix as 5 into 10 into 10 into 5, we get 5 into 5 matrix. Now we will multiply these two matrices. So number of multiplications required in multiplying these two matrices is 10 into 5 into 5. So 10 into 5 into 5 is equals to 250 again. So total number of multiplications required now is 1000 plus 250 plus 250. That is equals to 1500. So we get less number of multiplications here. So this is the answer. So you got why I took first these two matrices. These two matrices are taken first because 20 is multiplied only once here. So the larger number is multiplied if only once, then we will get the smaller value. If a larger number is multiplied twice, then we will get a very large value. So to determine a minimum number of multiplications, we have to multiply a larger number of B elements first. Okay. So the answer we get of this question is 1500. So thank you very much. We will again come with linear equations and eigenvalues and eigenvector methods, and we will also see some questions. So stay tuned. We will come back with the next lecture. Okay. Thank you.